So, dear students, Assalamu alaikum. Today we will discuss about electric field intensity. It's a vector. You can denote that vector by the symbol E. So you can say electric field intensity is related to the electrical force, the Coulomb force, by the equation E equal to F divided by Q. That's the equation. Okay. That's the equation for the electric field intensity. So it is a force. So you can define it as the force that unit charge experiences when it is placed in an electric field. Okay. For example, I'll tell you one thing. For example, suppose if you have one charge Q here, okay, you have a charge Q here, and you have another charge Q1 here, and I draw the vector from Q to Q1. Let me represent that vector by R1. Okay. Now the force experienced by Q1 due to Q, we can write it as F equal to Q1 by 4 pi epsilon 0, right? Then you have to find out the magnitude square, and you know the unit vector R. This is a force experienced by Q1 due to the charge Q, right? Now, instead of Q1, you have a unit charge, 1 Coulomb charge at that point. Then the force experienced by that 1 Coulomb charge is the electric field at that point. Okay. You know that the force F is experienced by a charge Q1. Instead of Q1 Coulomb, if you have a charge which is having a value of only 1 Coulomb, then the force experienced by that 1 Coulomb is called the electric field. So you can write the electric field as, right? You can write the electric field wait. Electric field as E equal to Q by 4 pi epsilon 0 R1 square, then A R1. So this is the force experienced by a 1 Coulomb charge. This is called the electric field intensity. So this is the equation for the electric field intensity. Okay. So suppose if you have a situation like I have many charges. For example, I have a charge Q1 here, another charge Q2 here, maybe another charge Q3 here. I want to know the electric field at this point. So I will draw a line like this. This is R1, right? And I will again draw another line like this. I will call that line R2 vector. And I can again draw the third line like this. And I can call that vector R3, right? So the total electric field is due to all these three charges, right? So I can write the total electric field as E equal to, you can write Q1 by 4 pi epsilon 0 R1 square AR1 plus Q2 by 4 pi epsilon 0, right, R2 square AR2 plus Q3 by 4 pi epsilon 0, right, R3 square A R3. Understand? R3 square. So this is the equation. So you can write it in a combined form like this. You can write it like this: E equal to, we can take out the 1 by 4 pi epsilon 0 outside together. 1 by 4 pi epsilon 0, right? Then I will write it Q1 by R1 square AR1 plus Q2 by R2 square AR2 plus Q3 by R3 square. That's it. So this is the equation. So this is how you will find out the electric field. Now suppose if you have an example, we'll write an example problem. I have 3 point charges, right? 3 point charges, like 1 millicoulomb and minus 2 millicoulomb. Located at T2 minus 1 and minus 1, minus 1, 4 respectively. That means that 1 millicoulomb is at 3 2 minus 1 and minus 2 millicoulomb is at point minus 1, 4. So the question is, calculate the electric force on a 10 nanocoulomb charge located at 0, 3, 1 and the electric field intensity at the point. Okay. So this is a question. So we will give the answer for that question. So you are supposed to find out the electric force on the 10 nanocoulomb charge at 031 as well as electric field intensity at that point. So you have the force is given by, right? Force is given by, right? You can write the Q by 4 pi epsilon 0, right? And you can write Q1 by R1 square AR1 plus Q2 by R2 square AR2, right? You have Q equal to 10 nanocoulombs equal to 10 into 10 raised to minus 9 coulomb, right? And you have Q1 equal to 1 millicoulomb, 1 into 10 raised to minus 3 coulomb. And you have Q2 equal to minus 2 millicoulomb, minus 2 into 10 raised to minus 3 coulomb. So these are the things, right? Now what is R1? You can write R1 equal to 0.31 minus 3.2 minus 1, isn't it? So it will be, you can write it as minus 3, 1, 2, isn't it? 0.31 minus 3.2 minus 1. So I can write magnitude of, you can write the magnitude of R1 equal to square root of minus 3 square plus 1 square plus 2 square equal to 9 plus 1, 10 plus 4, 14, right? That is square root of 14, isn't it? So what is R1? That is R1 divided by magnitude of R1 equal to, what is it? So it is minus 312, right? Minus 312 divided by square root of 14. Now what is R2? R2 we can write it as 0.31 minus 1 minus 1, 4, isn't it? So it will be 1, 3 plus 1 is 4, and minus 3, isn't it? So what is the magnitude of R2? It is square root of 1 square plus 4 square plus minus 3 square. That is 16 plus 9, 25, square root of 26. And you can write R2 equal to 1 and 4 minus 3 divided by square root of 26, isn't it? So now we can do the calculation. We will write the force F equal to you can see Q is 10 into 10 raised to minus 9, isn't it? 10 into 10 raised to minus 9 divided by 4 pi into 10 raised to minus 9 by 36 pi. That's epsilon, isn't it? Then you multiply the whole thing with what? Q1. What is Q1? Q1 is 1 into 10 raised to minus 3, right? You have 1 into 10 raised to minus 3 divided by R1 square, right? What is R1 square? 14, isn't it? It is 14. Then AR1. What is AR1? AR1 is minus 3, 1, 2 divided by square root of 14. Then the second one is Q2. That is minus 2 into 10 raised to 3. And 4 minus 3 divided by square root of 26. Let me make the calculation. So the result, after you make the calculation, will come to be something like this. Answer will be minus 6.512 AX minus 3.713 AY plus 7.509 AZ, okay, into 10 raised to minus 3 Newton. Or you can say this much millinewton. Okay, both are same. So what is the electric field at that point? Electric field is given by E equal to force divided by charge. So you can divide this thing by, okay, you can divide minus 6.512 minus 3.713 7.509 into 10 raised to minus 3. You can divide it by Q. What is Q? Q is actually 10. What is Q? Q is 10 nanocoulomb, right? So you can divide by 10 into 10 raised to minus 9. Okay. So you will get it something around like minus 6512 651.2 AX minus 371.3 AY plus 750.9 AZ kilovolts per meter. That's kilovolts per meter. That much you are getting the value of the particular electric field, right? So that's how you will calculate the electric field. And now we'll discuss a new topic which is called the electric field distributions. Electric field due to continuous charge distributions. New topic. Due to I think we will discuss this in the next lecture. That would be, I will be putting another lecture. In that I will discuss this particular thing.